Good morning, Math 10s. We are moving on to a new chapter in our workbook, and the chapter is Chapter 2, Exponents. This will be the first lesson, and it's on page 61. And this lesson will be part 1 of 2 for this lesson. One thing that I just want to quickly talk about before we actually get into the lesson is we've already done the chapter on numbers, and numbers leads into the chapter on exponents. After exponents, we're going to study something called polynomials, which is chapter 5, and then factoring, which is chapter 6. These 4 chapters, they belong into the strand of what's called algebra. So we're currently studying the strand of algebra, and there's 4 chapters within that strand. Each chapter, remember, there's always a test associated with each chapter, and then there's going to be a big unit exam that's going to be associated with algebra. Okay, let's get right into this. So on page 61, let's talk about exponents, and there's 2 different ways that we could write exponents. So if you have your highlighters, I want you to highlight repeated multiplication and exponential form. So what repeated multiplication would be is, let's say I give you the number 7, and I say multiply that number by itself 4 times. So 7 times 7 times 7 times 7. That is what we would call repeated multiplication. But then what I could do is I could write that in exponential form. So the base is 7, and the exponent, that is being repeated 4 times, so it's 7 to the power of 4, and this is what we called exponential form. We could do exponents, both repeated multiplication and exponential form, with numbers or with variables. So if I do variables, remember variables is just a mathematical term for letters. So for this example here, it says, okay, well, what's the volume of this cube? We know that the volume of a cube is length times width times height. So I'm going to look at the side lengths, and because it's a perfect cube, all side lengths are the same. So it's A times A times A times A times A. That would be repeated multiplication. And then in exponential form, I could say, okay, really, the volume is equal to A cubed. Okay? Powers. So you did do powers and exponents in grade 10, or sorry, in grade 9. So hopefully the first part of this lesson is going to be a review. But basically, if I have 7 to the power of 3, this 7 is my base. The 3 is my exponent. And the entire thing, which is 7 to the power of 3, I would denote that as my power. Okay, so you need to be able to distinguish between base, exponent, and power. So let's look at class example number 1. State the base and exponent in each of the following powers. So it should be nice and easy. So let's just write B for base and E for exponent for each one. And they want the base and the exponent. So base is 4, base over here is -3, base over here is x. The power is, or sorry, the exponent is 5, the exponent is 6, and the exponent is y. And that's how you would do class example number 1. Flip to page 62, and it says a number that multiplies a variable is called a coefficient. So let's highlight coefficient, and a number that multiplies a variable. Okay, so let's look at a different, I always like to give a different example from the workbook so that you have more than one example when you're studying. So if I gave you, let's say, a to the power of 4, that is my variable. My variable is a. A is my base and 4 is my exponent. This is my power. If I put a number in front of this variable, so I'm going to put a 5 there, that 5 is what's referred to as my coefficient. And what it basically is, this is you could read it in one of two different ways, 5a to the power of 4, or really what this is 5 times, so I'll put my little multiplication, 5 times a to the power of 4. Okay? State the coefficient in each of the following. So let's look for the number in front of the variable. So the coefficient is 8. This coefficient is -3. This one, C, let's star C. So if I said, okay, what's the number in front of this a to the power of 8? There is an invisible 1 there, which I hope everybody realizes. Now, the coefficient, though, is not 1. How I could rewrite C, this is really 1 over 7 times a to the power of 8. Therefore, my coefficient is 1/7. So just make sure you're good with C. Okay, class example number 3. Write each of the following as repeated multiplication. So my coefficient is 3, and then I've got 4 A's, and I've got 1 B. Next one, I've got a 3, and then this 4 applies to the AB. So essentially what that means is I could write AB 4 times. That is one way you could state your answer. And then sometimes students will say to me, okay, Mrs. King, well, can I write it like this? They'll say, can I put the 3 first and then do 1, 2, 3, 4 A's? And then can I do the 4 B's? And the answer is absolutely. So for a question like C, I would accept either one of these as an answer. These 4 B's should actually be attached up here. I'm just running out of room. Okay, let's do B. B actually, hopefully you could do yourself, right? So B and D, pause the video and try it, and then unpause the video when you're done to check my answer. Okay, B. Coefficient is 3. There's 1 A, and there's 4 B's. So that's how you would do B. D, this exponent is outside of the bracket. So there's two different ways that we could write this. You could write this 3AB 4 times. Okay, so you could do that. You could say 3AB, 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 3AB. You could do that. Or when we get into part 2 of this lesson, what I'm going to show you is that this exponent applies, that 4 applies to everything in the bracket. So it applies to the 3, it applies to the A, and it applies to the B. So the other way I could write this is there's 4 3's. So 1, 2, 3, 4, right? I could put those first. And then I could say, okay, take that 4 and apply it to the A. There's 4 A's. Take that 4 and apply it to the B. There's 4 B's. And that's how I would do that question. Evaluating powers. I'm going to show you how to do this on your calculator. So 10 to the power of 3, you know, written in expanded form, that's 10 times 10 times 10. On your calculator though, so let's make sure everybody's like proficient using their calculators. This is your power button. It's right above your division button. 10 to the power of 3 is 1,000. 3 to the power of 4. So 3 to the power of 4 is 81. This is important, these two. So -6 in a bracket squared is -6 times -6. Two negatives are going to give you a positive, and we're going to get our answer as 36. So if you look for this one, how I'd enter this is exactly how it's written. Open bracket, -6, close that bracket, and then I could either square it or I could have done that power button, right? But -6 squared is 36 because -6 times -6 is positive 36. This one here, I'll just sort of show you what this really is. This is really, that negative is -1 times 6 squared. So what that would be is -1 times 6 times 6, and this answer is negative 36. So if ever you see a negative and there's no bracket, rewrite that as a negative 1 times whatever your base and exponent is. When I enter this on my calculator, negative 6 squared, so there's my negative button, 6 squared, I get negative 36 as an answer. Okay? Um, the zero exponent. So let's star this. I can't remember if in grade 9 you do the zero exponent, but the zero exponent is going to be huge in high school. Okay, basically, what I want you to do is I want you to type in on your calculators to see what the zero exponent is. I want you to type in 3 to the power of 0 and 10 to the power of 0. So type in 10 to the power of 0 for me, 3 to the power of 0. What answer do you get? So I'm going to clear this and let's look at the zero exponent. 10 to the power of 0 and 3 to the power of 0 is 1. So any number or variable that you put to the power of 0, your answer is always going to be 1. That is what the zero exponent is. Okay? So it says the results above are examples of a general rule when a base is raised to an exponent of 0. Complete the following. A to the power of 0. It doesn't matter what a is. Anything to the power of 0 is 1. So when we do this question, class example number 4, it says evaluate the following. 6 to the power of 0. So you say, okay, I'm not even going to type that in. That's 1. This bracket to the power of 0, you could type it in, is 1. So let's actually type in B just to double check. Negative 9 in a bracket to the power of 0. So open bracket, negative 9, close that bracket, power of 0, and I get 1. C, I want you to star. The answer to C is not 1. And let's actually look what the answer is, and then I'll show you why they get that answer. Negative 9 to the power of 0. So negative 9 to the power of 0. They get negative 1. So let's see if we could figure out why they get negative 1. I told you up here that if you have a negative in front of a number and there's no bracket, that's really negative 1 times 9 to the power of 0. This would be negative 1 times 9 to the power of 0 is 1, and negative 1 times 1 is negative 1. So the answer for C is negative 1. Okay, let's look at D. This bracket is to the power of 0. So what that means is this bracket to anything to the power of 0 is going to be 1. Okay? But in front of that bracket, there's a 2 there. So 1 times 2 is equal to 2. So that would be the answer. So again, this bracket to the power of 0 is going to give you 1, and then bring down that 2. 2 times 1 is 2. That's going to be the end of the first part for lesson 1 in the Exponents chapter. We're going to circle questions 1 to 4, and I want you to do questions 1 to 4 before before you watch part 2. So there's question 1. Here's question 2. So question 1, nice and simple, state the base and exponent. Question 2, state the coefficient. Question 3, write the repeated multiplication. And question 4 is evaluate. And I don't know why I don't have it. We need question 7. So make sure you are doing 7 and actually do 6 as well. So I'm going to add this. So please make sure you're doing 6 and 7 as well. Okay, and that concludes part 1 of this lesson.